Hello, good morning. Welcome to this BD4ENEF workshop. And I am Nikos Mitropoulos from National Technical University of Athens. I will do at first a little presentation of our project BD4ENEF, and then we will discuss a little bit with the other speakers, Nikos Belidis, the technical advancements of the project, and then we will dive a little bit deep on our two pilots of BD4ENEF for energy efficiency. That will see more in detail presentations of what we have achieved in two of our pilots. Let me share my screen. Okay, and should be okay. Okay. So a little bit about our project. This project started almost 3 years ago. It now reaches its end. We're proposing our final outcomes with delivering of latest results. A little bit for the background, what was BD4ENEF's vision was to deliver an innovative energy-specific open analytics modular framework. We wanted to enable and realize an incremental decentralized energy data-driven ecosystem. We do research, so we wanted to integrate state-of-the-art technological advancements for data-driven ecosystems. To unlock and exploit the economic potential of big data in the energy sector and use and develop to enable AI-based cross-sector analytics for smart energy grid management. All this can be seen here in a more detailed way. This presents our vision, what we wanted to do. In general, the idea is for many related actors of the energy ecosystem are present on this project. We have a decentralized platform, a BD4ENEF governance, a BD4ENEF processing, and a BD4ENEF analytics, all of which tackle different aspects of energy data, decentralized data sovereignty, edge computer resources, storage resources, big data, smart grid algorithms, and machine learning model analytics. And eventually, all this can be offered through a dedicated marketplace in which energy-related stakeholders can share data, can share models, can share libraries for different applications in the energy sector. This application all fall under three pillars: BD4NET, BD4DER, BD4ENEF, in total of 12 pilots, all of which tackled unique applications in the energy sector. A little bit more in detail of how we worked through our project, our technical solution, and how we tackle these issues. We have our data hubs coming from energy actors, DSOs, TSOs, market operators, non-grid assets owners, citizens, machines in general. All this come from our pilots and from open data sources. We handle this data through the governance layer, BD4ENEF governance layer, for multi-party data sharing, off-chain data sharing, in order to integrate and homogenize this data. Processing this data with scalable big data solutions is to enable this data to be shared within BD4ENEF, within the different actors, and allow us to create AI models and applications for our piloted applications. So you can see there that the processing layer has different applications for smart data management and processing, intelligent information broker, AI, edge, and resources. All of this you'll see in the later presentation regarding our technical advancements. The pilot application all have AI services, AI analytics, prescriptive analytics, visual analytics, descriptive analytics, predictive analytics to tackle these different layers, this problem network reliability, improvement of flexibility, distributed edge resources flexibility, management energy efficiency improvement. So the three pillars of BD4ENEF are with pilot, our 12 pilot, our BD4NET, which are for predictive analytics that can forecast and increase the efficiency and reliability of the electricity network. BD4DER to optimize the management of assets connected to the grid, and BD4ENEF to increase the efficiency and comfort of building and de-risk investments of energy efficiency. Today, we will present and discuss results of two of our pilots of the last pillar, BD4ENEF. But before that, maybe a little bit I can show you, to all of you attending here, the pilots in general, the 12 pilots in general, but in very brief time period. So in BD4Net, you can see here the use cases, the applications we wanted to solve within our project, leveraging on our technological solutions. We have one pilot to integrate off-grid data with condition-based monitoring to enhance predictive asset maintenance. We have another pilot to cross-function integration of grid operation and predictive asset management. We have a small local DSO for cross-domain functional integration of predictive asset management, and to cross-functional predictive asset management for medium voltage grid planning. All these four under the BD4Net category. These are all TSOs, DSOs. So this pillar tackle this type of energy actors. You can see more. Also, we have a workshop tomorrow for this type of pilots, if you want to see a little bit more deeper of what we have achieved in this pillar. It's BD4 there, and the other pillar for to enable the flexibility of distributed energy resources. We have 5 pilots in this pillar. One pilot is for cross-stakeholder transfer learning for flexibility asset forecasting. Another pilot, we use BD4 energy solutions to coordinate grid-owned and behind-the-meter asset management prediction. Another pilot uses predictive analytics forecasting for storage optimization. In another pilot, we use predictive demand and generation forecasting to optimize local energy communities in a small island in Greece. And another one pilot, the final pilot of this pillar, is for predictive demand and generation forecasting for optimized local energy community management. These are the 5 pilots of this pillar of the distributed energy resources flexibility enabling. And the final one, before we go a little bit in detail, actually, it's a BD4ENEF. It's to optimize, to minimize the risk of an energy efficiency investments. And we have 3 pilots on this pillar. The first one and the second one are the ones that will be presented in detail. So I will spare you the details. You'll see all about it later. And finally, our last pilot is to use predictive analytics for energy efficiency investments de-risk. This is our project in a very brief summary. Today we'll see 2 pilots of BD4ENEF, but before that, perhaps I can stop sharing now, as Nikos Belidis from European Dynamics will tell you a little bit more of the technical advancements, the technical solutions of what we achieved in our project.
Nikos, so let me share my screen. Can you see the full screen mode?
Yes.
Okay. So thank you very much. I'm Nikos Belidis. I'm a Senior R&D Project Manager in European Dynamics. And since we now saw a few things about the project in general, I would like to provide more details about the technical implementation of BD4 Energy, the whole technical framework and how it was designed and implemented before we move on to the pilots and to see actually how the pilots made use of and exploited this technical implementation. So, starting, this is a very general scheme that describes the interactions between the different blocks that we have created. So, basically, the technical framework, the technical implementation of BD4 Energy lies in the 2 upper layers of this figure. The main components are the data governance middleware, the analytics toolbox, and the marketplace. So the main idea is that the different actors and their assets act as data sources that provide data to the data governance middleware. The data governance middleware is responsible for processing the data, for harmonizing the data, for performing quality checks, and in general, it orchestrates the data ingestion and data pipelining until the data reach the analytics toolbox, where we have all the different analytics services and big data services that we have developed in the course of the project, and that perform the different applications, the different functions that are required by our end users. And finally, the marketplace is basically the access point to the BD4Energy framework, where the users can access the different applications and run them for their day-to-day operations. Now we're going to go into details for each one of the three main components of the BD4Energy technical framework. So we're going to start with the data governance middleware. We will proceed with the analytics toolbox, and finally a few words about the marketplace. Starting with the data governance layer, the main objectives, what we wanted to achieve was to ensure that best practices from big data management and modeling were incorporated into our design in order to result to to a governance layer that is allowing the seamless exchange of information and data between different interconnected assets, between actors, systems, etc., in a harmonized and common manner. Also to define a data access policy layer, which includes different definitions for different roles, for different specific roles, with different access rights based on their level of clearance on viewing sensitive data, in order to preserve the security and privacy of the data that are part of the BD4Energy ecosystem, and also to implement and propose certain legal, ethical, and cybersecurity recommendations in order to ensure that data are preserved and are not sensitive data are secured. Also to develop and configure the different modules that assure the quality of the retrieved data sets by performing quality checks, to develop a peer-to-peer blockchain-based application for smart contracts, to develop the data management enablers based on edge and IoT applications, including also elastic streaming data capturing management, and finally to build the interoperability and homogenization layer, which applies ontologies and semantics in a harmonized manner by following certain standards that are used that are widely used currently. If you want to visualize it in a flow, so how the data governance middleware works, it retrieves we can see the figure below, which shows that the middleware retrieves the datasets from the large-scale pilots. The data undergo different transformations, quality checks, the data are being integrated, they're being harmonized in order to be interoperable and to be able to be exchanged in a seamless manner. We perform also operational data support, and finally the data are provided to the analytics and the decision support. Here we can see the reference architecture of the BD4Energy data governance. This is quite detailed, and I'm not going to explain everything as it's not relevant right now, but I just want to convey the key messages. So on the left-hand side, we have the data providers, and on the right-hand side, we have the data consumers. Data providers provide data, raw data, which end up in the landing zone. These and undergo different data quality and compliance processes. The data are then enter the data ingestion zone, where we have both data in motion and data at rest. And finally, we have the data access and user interaction zone, where the interoperability and homogenization of the data takes place. We have there the query engine, so that the users can query the data according to the needs of its application. And finally, the data are provided to the data consumers. What is important to stress here is that we managed to achieve a well-functioning integration between the data access policies and brokerage functions and the integrated query engine. So as I explained also before, based on the role of the specific role of each user and the access rights to different levels of sensitivity of data, Each user can query only data that has clearance to, and no sensitive data are shared with users that are not supposed to view this data. Moving on, we will see a few things about a few details on the analytics toolbox, which is the second component of the BD4ENEF technical implementation. So basically, the aim is to develop all the data analytics and big data management services. And the aim was to analyze data seamlessly and holistically across multiple data sources and in different languages that operate across the entire data lifecycle. Also to deliver the libraries and algorithms for data knowledge extraction, for business intelligence and energy analytics, by delivering all the tools, the methods, and the frameworks for the processing, visualization, exploration, and curing of data, to integrate all the different modules of the platform with clear and easy to use and user-friendly interfaces and low level of interdependence, to create a scalable system so that we have the possibility to continuously integrate additional functionality to each module, and to consolidate and fine-tune the different modules that form the integrated BD4ENEF platform. The analytics that we developed in the project can be categorized in four main pillars. These are incremental, distributed, and self-learning analytics, cross-stakeholder transfer learning, declarative, predictive, and prescriptive real-time data analytics, and all the visual analytics, the dashboards, the graphical user interfaces, and report libraries that were needed. A few examples of these analytic tools that were developed in the project are mid-term photovoltaic production forecasting, load forecasting at a large scale at an island level, load shifting for water pumping systems, de-risking investments in energy efficiency in buildings, also in buildings analytics that have to do with the thermal comfort of the occupants, IPV-MVP, International Performance Measurement and Verification Protocol-based energy efficiency renovation assessment, power scheduling optimization between EV charging stations, storage systems, and PV panels, cross-stakeholder transfer learning, predictive assessment of power transformer aging, and as we said, all the visual analytics, the user interfaces, the dashboards, in order to visualize the data, the process data that come out of all the different analytics tools. Finally, the marketplace, as I already mentioned, is the place where the users can access the different applications. The main aims were to boost the wider use of the project results by opening new business opportunities in order to enlarge the market share of European data companies and to expand the scope of this BD4ENEF project itself and its ecosystem, to integrate and coordinate different services in order to provide the functionality that's required by the end users, to create loosely coupled and collaborating services, and to expose their functionalities through REST APIs. In the figure, we can see how now data that have now been processed come from the various sources which were already mentioned, from the governance layer, from the data catalog and data discovery services, from machine learning tools, and the machine learning library and other sources, and they are fed to the services where we have data services, machine learning services, third-party services that come. This proves also the scalable nature of the system, as the project launched its own open call, where we asked external entities to create new services for the BD4ENEF framework, and these were easily integrated within the service catalog of the project. Finally, all these are exposed through REST APIs, and we have developed graphical user interfaces that are user-friendly and through which the user can access the different services and applications. So in a nutshell, this is all from me. This describes briefly the whole technical implementation of the BD4ENEF framework, and now I think it's time to see how actually our end users, the pilots, manage to leverage this and in order to use it and integrate it in their operations. So first, we're going to, as Nikos described in the beginning, we have today we will focus on one out of the three piloting pillars of BD4 Energy, which has to do with de-risking investments in energy efficiency and increasing the efficiency and comfort in buildings. And I invite Victor Serna from Cardiff to say a few words about this piloting pillar. Thank you.
Thank you, Nikos. This is Victor Serna. I'm sharing my screen. A second, please. Can you see my screen?
Yes.
Yes, yes.
Okay. So I'm going to present a general overview of the pilots that are in this pillar, this the risk in investment in energy efficiency and increasing the efficiency and comfort of buildings pillar. So my name is Victor Serna. I'm telecommunication engineer and senior researcher at Cardiff. Cardiff is a research center that the objective of Cardiff is generating technological knowledge and innovative solutions to companies to improve their competitiveness. We are located in Castilla y León, in Valladolid. And Cardiff is divided in three main divisions: energy division, industrial and digital system, and agro-food and sustainable processes. And big data for energy project is located in the energy efficiency area of the energy division. So this pillar is related with the buildings and with the increasing the efficiency and comfort in buildings. It's important to know that is more than a third of the total final energy consumed in the European Union is consumed in buildings, in the residential and tertiary sector. So the idea is to boost these energy efficiency measures for different reasons: for reduce the energy consumption and greenhouse gas emissions, to reduce the import bills, to achieve a sustainable energy supply in order to improve this security of the supply, and also all of them is for increasing the competitiveness of the European Union. So the pilots, the large-scale pilots that are in this pillar focus in increasing the application of energy efficiency actions in buildings, but always taking into account the comfort of the users, of course, and increasing the investment in energy efficiency measures, which can be achieved by decreasing the risk of the investments. So for that, we have like 3 points to cover. One of them is to predict the energy performance of the building by dynamically confronting the EPCs, the energy performance certificates that maybe you know, but they are like a report that describe how efficient a home is regarding the consumption. So the idea is to confronting these EPCs and the real energy consumption information from monitoring or so on to provide actionable information. Other point is to encourage a business model that facilitates energy retrofitting action when you focus on improving the thermal comfort. And to reduce the other one is to reduce the uncertainty associated with the energy efficiency investments, exploring past and future information. The services that are developed here are mainly adapted to energy services companies and also for financial institutions. We have 3 pilots in this pillar. 2 of them they will be explained later, LSP 10 and 11, and the 12 I am giving some notes about that. LSP 10 is predicting and prescripting analytics for improved energy performance certificates, and the leader is Cartif, and it works very closely with Veolia, and is located in Spain, mainly in Castilla y León region. Other pilot in Spain is LSP11, that is this weather-enhanced building thermal comfort prediction to enable energy efficiency reliable forecasting. That is, the leader is Ayuntamiento de San Cugat del Valles, and also is located in Spain, and works together with Veolia and N2A. And the last pilot is LSP12, that is predicting analytics for energy efficiency investment de-risking, and is located in Latvia. And the leader is Leif. So some notes about every pilot. This LSP10 pilot is related to this energy performance certificate, and the idea is to increase the trust on these reports. For that, we have taken advantage of the energy performance information, extracting the knowledge that we can extract from them, and in order to boost the use of the energy performance certificates. Regarding the LSP11, the idea is focusing the building and in the comfort, and for that we forecast the energy needs, propose a working schedule of the HVAC system, always taking into account the needs of the user, the comfort, the building use, and the weather forecast. Regarding the LSP12 is related to the energy efficiency investment. For that, we use real data from energy efficiency projects in order to predict the value of energy efficiency investment, categorizing this investment, and estimating the actual energy savings. For this LSP, I'm saying more things about that. The pilot leader is Leif, and is supported by N2A. And the service developed allows to quickly and easily assess key project performance indicators, analyzing and evaluating different methodologies for projects and companies, comparison tools, financial indicators for investors, and so on. And also to explore past and future projects, using the project history, brief description, project, and companies more attractive to investors. And last is to conduct a comprehensive risk assessment, incorporating key indicators such as the debt service coverage ratio, complying with legal requirements in environmental legislation and regulation. There are two main services in this LSP. One of them is energy efficiency investment, and the objective of this service is to provide information about the implemented projects in Latvia. Here you can see the conversion matrix of the energy efficiency assessment model that is used for this service, and here you can see an example of the things that the user can see in the graphical user interface of this service. And the second service of this LSP is the calculation of actual energy savings. The objective is to calculate and predict the percentage of funding for user project. And you can see here results of the energy savings calculation for each Latvian buildings. And also here you can see another example of the graphical user interface that showed to the user different things, the project with high potentials, with medium potentials, or with low potentials, and so on. More or less, this is the information that I give about the LSP12, and in the later presentation you can see more information about the two other large-scale pilots. So maybe right now I think it's Pablo Marcos to comment, to present the other one. So
yes. Good day. Thank you, Victor, for your presentation. I'm going to share my screen. Okay, do you see the screen, right?
Yes, not in full right now. Yeah.
Okay, so this is Pablo Marcos from Veolia. I'm going to introduce you in the large scale pilot 10. We will see some contents about the challenge, the specific components, and then we will center on the specific actors or stakeholders. And finally, we conclude with the analytic services, key components, results, and a final overview from the aftermath of assessments. So, this is the large scale pilot 10. Veolia is involved here. We design and deploy solutions for water, waste, and energy management, participating in the sustainable development of the cities and industries. So this LSP10 aims to improve the reliability, performance, and compliance of energy performance certificates using predictive and prescriptive analysis from all public and private data collections, such as the cadastre, regional EPCs, and energy management systems, in order to create a dynamic version of the existing IPCs. So from Veolia, there are 4 buildings monitored by Veolia and located all of them in Castilla y León, which provide very useful data for the development of this LSP10, such as the energy production and consumption data from the boilers or facilities, boiler operation hours, ambient temperatures in different areas, and also operating temperatures of the thermal circuit. These 4 pilots, firstly, one of them is Casa del Barco, which is an administrative building located in Valladolid. Secondly, in Burgos, Sagrado Corazón is a school, and together with the residential building Tejera 2, which is more specifically located in Aranda de Duero. And finally, La Medilla was chosen as a health center located in Salamanca. So, what are the specific components of this challenge? Well, the tool uses various platforms to efficiently handle data management, storage, modeling, and analysis tasks. First of all, a Python programming environment with essential libraries such as scikit-learn is needed to build and deploy the predictive models. And in addition, a dedicated relational database, which is PostgreSQL, is used to store and manage the project data. This database is selected for its robustness, scalability, and reliability, making it an ideal choice to support the backend operations of the services. And on the other hand, the public data from the Castilla y León region, including energy consumption and EPC information, along with the Veolia buildings and meteorological data, are securely ingested and loaded into the dedicated relational database using Python scripts. So this specialized database serves as the central storage for all the project-related data, ensuring efficient management and storage. Regarding the specific actors or stakeholders, first of all, Veolia, as an internal actor with the BD4ENEF project, plays a crucial role because they are responsible for providing essential data and ensuring its quality. We also actively engage in all stages of the project, from data provision to evaluating results. And their ongoing dedication includes sharing data and providing regular updates. So the main beneficiaries of Veolia's involvement are the project itself, which heavily relies on their data, and in return, Veolia benefits from the use of the data to develop services that accurately predict energy efficiency values and enhance the reliability of the EPCs. saving time and resources in the process. Additionally, we mentioned the Junta de Castilla y León and 4 privately owned buildings belonging to the Veolia Corporation. So they are mentioned in relation to the data used for the energy prediction service. Then Cartif, which is leader in the work package like Scale Pilot 10, as an internal technology developer, has a main role in driving the technical aspects forward in the BD4ENEF project, because they are actively contributing to all stages of the project, with the particular focus on developing and training models for analytical services. And these models are essential in ensuring accurate and efficient energy predictions. They collaborate closely with the other project partners, of course, to successfully integrate the developed technologies. So the primary beneficiaries of the involvement are the project itself, again, which relies on Cartif's technologies for precise energy predictions, and their expectations will focus on effectively harnessing the developed technologies and safely integrating them into the project framework. And last but not least, the public entities, the EU member states, among other external actors, have a stake in the BD4ENEF project because they play an active role in various stages of the project, including monitoring energy forecast and evaluating the effectiveness of energy conservation measures. And the expectations centers around validation and participation in activities related to the primary beneficiaries of their involvement and the providers of the data and developers technology. Okay, so now continue with the analytic services. In this large-scale pilot 10, the incorporation of the BD4ENEF operational activities has had a significant and far-reaching impact. This initiative brings about a revolutionary change in energy performance certificates by utilizing predictive and prescriptive analytics. They've been establishing new benchmarks in the industry. To reach this objective, the analytic services have been developed. First of all, energy prediction based on real data, number 1. Then considering climate change impact, which is number 3. And finally, EPC estimation based on public data at urban level from Castilla y León, Spain. The development of these services will contribute to the building energy retrofitting, making them user-friendly and cost-effective through a better energy transition and EU legislation compliance. They leverage cutting-edge machine learning algorithms to seamlessly integrate a wide range of data sources. And these sources include public building energy consumption data, real-time and historical building consumption data, weather data, and contextual information, as I mentioned before. Okay, first of all, regarding the energy prediction service, relies on a diverse range of data sources and contextual information to provide precise forecast of energy consumption in public buildings. These sources include historical and real-time data on building energy usage, weather data, both past and future forecast, and relevant contextual information such as building types and occupancy patterns. So the service is designed to generate energy predictions for different time frames. And to adjust its forecasting timelines, the energy prediction services utilize machine learning algorithms based on the available data. It employs various forecasting methods to model different assets like thermal and energy demand, aiming to determine the most common accurate models. So the primary data sources for this service are the energy consumption records of the public building in Castilla y León and the monitoring data from Veolia buildings, right? So by combining data from these sources and utilizing adaptable models techniques, the energy prediction service ensures it can deliver timely and reliable forecast of energy consumption for a wide range of building scenarios. So this contributes to improve energy efficiency and facilitates informed decision making. Okay. On the second one, the energy performance calculation, but based on public data at urban level. The city level energy performance calculation utilizes public data to estimate certain parameters included in APCs, such as heating and cooling demand, consumption, more specifically non-renewable primary energy, for instance, and CO2 emissions. This estimation is based on data obtained from public sources, enabling the calculation of APC values for building in a specific location. And to achieve this, various types of information about the building are required to characterize it and estimate the different parameters found on the EPCs. This includes data from land registries and public EPCs. Multiple machine learning algorithms are employed and tested for these calculations. And at the end of the day, the ultimate goal is to estimate EPC labels that provide insights into the performance of the buildings with a given location. These labels serve various purposes, including planning tasks, identifying inconsistencies, and comparing building performance. So the results are displayed on a map in an intuitive and user-friendly application, as you can see. And the third one, energy prediction, but considering climate change impacts, is based on analyze the effects of these changes on energy demand and consumption, particularly in relation to variations from the baseline and their influence on heating and cooling degree hours. So by considering how the temperature will change in the future, the service examines its impact on heating and cooling needs, while also accounting for the effects of solar radiation on building thermal gains. This service provides an estimation of certain parameters found in the EPCs, energy performance certificates, heating and cooling demand, energy consumption, and CO2 emissions, and it relies on data public sources like Adaster, LIDAR, or PVGs. The calculation of energy demand is conducted on an hourly basis and then translated into a daily basis to determine energy consumption and emissions. So this approach enables the estimation of the future EPC values for public buildings in a specific location, taking into account the effects of climate change and its influence on energy demand. Okay, so how BD4Energy was integrated in the pilot activities? What was the aftermath of that? In summary, the initiative's commitment is demonstrated through the utilization of diverse forecasting techniques and detailed hourly data modeling. And this approach significantly enhanced the dependability of EPCs and established the LSP10 as a trailblazer in technical excellence for energy performance prediction and management. Beyond technical advancements, the BD4Energy initiative has a broader impact on the business landscape by increasing the value proposition of EPCs. The EPCs not only benefits energy management practice, but also stimulates growth in the energy retrofitting industry. It also accomplishes this by providing user-friendly and cost-effective solutions that stem from the enhanced reliability of EPCs. And moreover, LSP10's efforts extend to ensuring compliance with regional energy efficiency standards and EPC regulations. So all of this contributes to reducing compliance-related risks for businesses operating in the building sector. So in a nutshell, in summary, the BD4Energy initiative, spearheaded by LSP10, which saves operational activities by prioritizing precision, efficiency, and reliability in energy prediction and management, leads to more accurate outcomes from Veolia, while opening up new business opportunities and minimizing compliance risks in the energy management and retrofitting sector. So that's all from my side. Thank you very much.
Thank you,
Can you
Pablo.
see my
I think, yes, we can proceed with the next pilot presentation, which is from Gerard Riba, and it's from Sant Cugat, and it concerns the pilot on weather-enhanced building thermal comfort prediction to enable the energy efficiency, reliable forecasting. So, yeah, please, Gerard, the floor is yours.
Thank you, Nikos. Can you see my screen?
Yes, yes.
Yes.
Okay. Thank you. Okay, my name is Gerard Riba. I'm the head of the maintenance service of the municipality of Sant Cugat del Vallès. And it's a pleasure for me to present you the initiative. We've been working with Veolia and Cardiff and the rest of the partners. First of all, to show you the content. The content is very similar that shows Veolia. There's an introduction of the city, the LSP, and the description of specific key components and analytic solutions and results at the aftermath of the beginning. Just to introduce our city is Sant Cugat. It's very close to Barcelona. In fact, there is the same frontier between both cities. In fact, it's very well connected to Barcelona as well, at the highway crossing all the region. In fact, time ago, it was a neighborhood from Barcelona. The people was living here and working in Barcelona, but now it's starting to be a hub. It's an technology company because it's really well connected to the rest of Catalonia, Spain, and Europe. Talking about the size, we have to understand we like to think that we are a green city because we are 44% of our area is protected, and we are surrounded by a natural park. And to understand how is our size, we are 95,000 inhabitants, close to 100,000. And it's a city, it's a young city that has grown up in the last 20 years, at least 60% of the population. It's a young city coming from, mostly of them from Barcelona, of all the rest of Catalonia, and there are big companies. And it's a people with a high knowledge, or high level of studies in the university. So these people, they are asking to us for the good solutions and the better solution for the municipality, and as well to reduce our footprint, because we're really aware about the climate change. As said Victor in his presentation, the motivation to do this pilot is just to understand that 1/3 of the energy consumption of the Europe is coming from the building. So, as a public administration, we have to find a solution to try to reduce this consumption, not because our impact is really. It has a big impact to all the energy consumption of the city, but to be a pilot to show new technologies to can be developed in a private sector, and we have many of buildings, in total 88 buildings, municipal buildings. So it is a good place to pilot and test new technologies and to show to the sector market to try to develop it. The primary goal is to find energy retrofitting actions. That those action is not a construction action. This action is just to change the behavior of the users, and it consequently the behavior of the buildings. If we understand that all the buildings are the same building, can have a different consumption depending of the user and how they use the energy, and we can understand like a living in the building. Of course, it was very easy to just to switch on the energy consumption, the HVAC systems, but the solution, of course, we have to give a comfort to the users, but trying to use the less energy as possible. What we have tested in this pilot is 2 buildings. In fact, there was a 3rd building, but at the end we couldn't finish and to find a real values, conclusions enough to be presented here, because it shows how sometimes to get information on the data, and you have to take into account that each of the building has a different systems to produce the energy. Sensors in your building and of meters to check what's happening and how to control the system. Two buildings tested. The first one is a civic center called the Solar Civic Center. It's a neighborhood in San Cugat. It's a place where it has a civic center. We can do NA classes, cooking classes, dance classes, and many activities that can use from the neighbors of the city. The second one is a Pindes Valles school. It's a school. There are around 400 students there, and it has a production from the geothermal system, and as well from photovoltaic. It's connected to the grid, so it's not even used for the school, but it's connected to the grid. And it has the capacity to store this energy. Not the same in the civic center. Minnesota has a big tank to store the energy and as well to produce with solar panels. The specific actors and stakeholders in the pilot have been the maintenance service company, in this case is Veolia, and who they have the expertise to manage the system. And it's the people who is working every day over the systems and controlling that it's working fine. Data providers to give us the information and to know better what is happening in the building, just to improve in the future and to use that information, that data set to do new machine learning algorithms. Of course, the San Juan City Council, that's owners of the buildings, were one of the stakeholders. The BD4ENEF partners, just to know to have a knowledge to be trained in these kind of buildings. And of course, the building users, the people that are using the building, and was the people first affected for the conclusion of the system. The key components of the infrastructure that they use monitor decided the installation, the building. So it's important to have a building energy management system, advanced, will give us the main information of what is happening in the building. So it's saying the room temperature, the windows, if they are open and closed, the temperature, the relative humidity of the rooms. It's important as well to say that each building are different, so each building has its own characteristics. So sometimes when we try to give a solution, we have to understand that not always we have the same baseline, so we have different information, and that to find a general solution sometimes it's not easy, but that's what we have now here, not in San Juan, in all Europe, with the different buildings, with the different technologies. The data frequency was from 1 to 15 minutes, and the information was stored in the banks, sometimes not in the cloud, but then in the server from the pilot, for example, in the local servers. Another information is the REST production, the production of renewable energy, and how to access to this data. And that one was the weather public data, about and the connection and integration with the BD4ENEF components. It was the way to have the analysis solutions. First of all, that is historical data. It was sent from CSV files, and this data was pre-processed for the partners and stored in a relational database. As well, was integrated with the integrated query engine, just to help us to do the wires and give a solutions. And of course, just to guarantee the security of the use of the data, it was performed through identity and access control management. The analytic solution provided for the partners of the BD was formed for two models. First one is the forecasting model that gets all the information, the outdoor temperature, the room temperature, how the HVAC systems of the buildings are working. And from there there are two models to detect the humidity forecast, the temperature forecast, and as well how the HVAC system should be operating. The second one, it was the thermal comfort model. The idea is just to give values and how can change the different way to act or way to manage the HVAC systems. First of all, to know if on the HVAC system to how to work, how to operate, and as well the team values. I mean, how comfortable is for the users to ordinary operation of the system and the recommended operating system from this pilot, and as well how many times we are not in the values that we can say that there is a comfort for the users. So how many violations are of the solution of the comfort solution for comfort state for the users. Here you can see the service provides. There is a table of schedule for the operation of the HVAC systems, and you can see in the first graph the blue lines will be when they should be operating the system, and comparing with the real one, the ordinary working system now. As well, you can see the number of violations of the values observed. If you compare in the first building, the Middle Sol Civic Center, and the first row, you can see in the business as usual the number of violations, and the proposal is a little bit higher, in at least in 4 of the 10 rooms of the Civic Center. The other 6 practically is the same value, so there is no problem. Only the room number 2 was the worst one, because we comes from 5.14 violations to 16, so it's a little too big, but there was why we have this violation if you compare, and that's important. One of the main goals of the pilot is just to reduce the energy, and with the proposal system can reduce 69% of the energy consumption of the building. So it's a big goal. It's very promising and encouraging us to try to do this proposal, this new way to operate with HVAC systems, rest of in other buildings. The values are very similar in the second building. This reduction of energy is not so big, but it's 49%, so it's important. And it's still more important is we have to reduce the number of violation of the comfort values. So we can go from 51% in one on the sides of the building to 28. So it's a great quality. Still too big, we can say 28, but at the rest you can see it from 10 to 0 to from 24 to 0. The results and the specific IPE used here was to have the building comfort conditions, the baseline. Since before we came from 1.32 to 22 in the second building, and we reduced to 8 and 7.2 with the system. The energy savings was 69 and 49 in each building. And if we're talking about the efficiency measure we proposed, the energy efficiency measure we proposed, we will say there is one, and the one is not we have to do anything, just to try to scale this solution or this way to work in another or to operate in another buildings. The number of buildings in the target was 3 because, as I said at the beginning, the Sankuwa City called at the end because the inconsistency of the data, data wasn't, so there is lacks of the data. the aftermath of the project. And if talking about the operational impact, the schedule presented in an analytic solution gives us a 1 week operation mode for each of the buildings. So that means every week we have to check that, and as well to week. So it means people have to be in care about everything is going as we expected. It's a technical impact because we cannot replicate this solution if we don't have the sensors, the meters, and a BEM system to manage and control. So we cannot replicate it in all the buildings, just when we. Otherwise, we should have that, and it supposes a municipality, but when we have it in the building system is easily scalable. As a business impact, I think the most important is to say that how can the energy consumption can be reduced, and that's the first business impact, but as well give us the opportunity and not only to reduce for the municipality the bill energy. Is also important to show to the citizens, to show to the market that there are solutions we can implement, and with a real return cost of money for the owners of the buildings, and as well with the third companies, just to increase the knowledge and how the buildings are working in real time. Next steps should be to develop a friendly interface for users and maintenance service company, to use the toolbox generated with BD4ENEF for another municipal buildings, to include the real-time data sets. As I said, we have using the historical data, and will be very interesting to try to use it. So not always is easy, because to access all this data, we are talking about and some of the data are very restricted. Be wired or consulted for an very nice to do that. Means that you have to different sensors, and just to be equalize the variations and the information you have from each building. And of course, there is a big opportunity to add data receipts, meaning the energy price. For example, it could be very interesting if you have the capacity in the building to storage the energy and to just consume from the price is lower, and use the energy storage in the building. So this is all from my side. If you have any question, of course.
Thanks, Gerard. So I think that with this we now end the presentations of the pilots, and we have still one session with Q&A. So we invite people from the audience to ask a question. You can use the chat in the chat in order to type your question, and please also let us know if you wish any specific speaker to address the question, and we can facilitate this. So, do we have any questions? Okay, I already see a couple. So, we have one. Can you mention examples of synergies or knowledge sharing opportunities that have arisen during the project? So, do we have anyone that would like to answer to this question?
Maybe here, Victor, for the general pillar. Yes, for example, examples of synergies. For example, there are different functionalities that has been developing for some specific pilots, but can be applied in other pilots. One example is the data quality mechanisms that are for a pilot, for the data for a pilot, but can be used can be replicated for other pilots, or specific functionalities, specific analytics. For example, the photovoltaics production forecast that has been developed for different pilot and other pillar, but can be applied in the pilots in here, and also the predictive maintenance activities or of the installations of other functionalities, estimation of the aging of the system that have been developed for a pilot, but can be applied for some other pilots.
Thank you. Maybe we can move to the next question. So, what are the main problems you encountered in accessing building data? Someone who would like to
I don't
answer?
think that question is for me, for San Cugat. I think the main problem we have is the heterogeneity of the data. So all the buildings have the same information, the same sensor. So we have to manage with different kind of information. Manufacturers, some of the information works in the cloud, some of the information works in the server. So the capacity as well to manage the system remotely is not the same for each BEMS. So what's the main barrier that we find to access the data as well? Because as a public administration, the data is not available for everybody. So there's a firewalls on the access of the data. That's a thing that the BD4ENEF partners they feel in the scheme, because sometimes, the example, the city hall from San Cugat, some of our department wasn't agree to give that information for security reasons as a public administration, and that big problem that we find access to the data.
Thank you very much. And we have two more questions. So first, what is the significance of utilizing AI services to forecast energy performance values in buildings and enhance EPC reliability? Answer for this one?
Yeah, just in essence, the use of AI algorithms allows to more accurate predictions of a building's energy performance by analyzing large amounts of data. This is not only saves time, but also leads to significant improvements in efficiency. And these algorithms are capable of detecting complex patterns, providing more accurate, more precise forecasts. While with reliable prediction of energy performance, stakeholders such as end users and facility managers can make informed decisions. They can prioritize energy efficiency improvements, allocate resources effectively, and identify potential inefficiencies. Moreover, regulations and standards related to energy efficiency can vary across regions and countries, and AI services can help ensure compliance by providing consistent and reliable analysis. So, in summary, AI services contribute to energy savings, time efficiency, and as well informed decision making. Yeah.
Perfect. Thank you very much. And finally, one last question. What are the challenges in relation to the large number of heterogeneous sources and the adoption of modern ICT infrastructures?
Okay, I can answer that. I think relating the sources, the data, one of the main problems is the lack of awareness of the potential, because I think the owners of the data has not the awareness that the data can be used, or we can extract information from, extract knowledge from this data. So one of the problem is this, but also the diversity of the format used for the data. That we have to deal with a lot of different formats that are it's not easy to take the data and to relate the data between them and so on. And also the reliability of the data. Sometimes the data, for example, the cadastral data is not maintained, or it's not always maintained. We have found a lot of errors, and perhaps also the low rate of update for the public data is another problem. I think it's for that it's important to use the standards to generate and consolidate the standards in this way to use a most appropriate ICT infrastructure, taking into account the data is standard and we can process in the same way. So I think it's that is the problem is that, and maybe this part of the standard could be solved part of the problem.
Thank you. And I think indeed this question was a really nice closure also for the workshop, as it conveys very good messages because that are also very relevant to the project and what we are trying to achieve. And it's not only the technical challenges, as you mentioned, that we are trying to tackle through this data harmonization, the application of standards and everything to make the data exchanges easier and more seamless and flexible and everything. But as you very well mentioned, it's also the awareness that of the people. We need to raise awareness on the advantages that these technologies can bring, not only to system operators, but also to simple users, to everyday citizens, etc. So I think that this should be a key message to communicate for future research actions, that we need to put the users, the consumers, every type of users in the center and try to make the solutions that we propose more interesting to them, and to highlight the importance of our solutions, to how they can help, these solutions can help the users in different day-to-day activities. So I don't know if there is any other comment from anyone. Okay, in that case, I think we can end this very interesting workshop. I would like to thank the people who joined online to participate, to watch this discussion, these presentations, and of course our colleagues from the BD4 Energy project, our panelists who were here today to assist us in this discussion. So, Nico, I don't know if you would like to say something before we close.
No, thank you all for the presentation. Thank you all for attending. We also host a workshop for another pillar tomorrow, so follow our social media sites if you wish to register and attend that one too.
Perfect. Yeah. So we hope to see most of you tomorrow again, and thank you for being here, and we wish you a nice rest of the day. Thanks a lot.
Thank you.
Thank you.